what average kinetic energy per mole does the kinetic theory of gases predict? So we've already seen this expression for the average kinetic energy coming from the kinetic theory of gases, and it was 3/2 kT. And the interpretation of this is that this was the average kinetic energy for one molecule. You could also say per molecule, but that implies that the kinetic energy for a large number of molecules n would be equal to this thing multiplied by n. And the n that I'm talking about here is a capital N that represents numbers of molecules rather than number of moles. So another way that this result could be expressed is this way. I took off the bar off of it because it makes sense if you're talking about a single molecule. They're not all going to be identical, so this would have to be an expression of the average. But if you're talking about n, and it's some number times 10 to the 23, because maybe it's some number that would be like a handful of moles, or maybe 1 or 2 moles or 5 or whatever, right? Then n is really huge, which means this is going to be, to a really good approximation, exactly correct without having to state average. So that's why maybe I don't need to include that there. But I'm being asked here for an expression for the average kinetic energy per mole. What we just saw in the last example is that there's a relationship between n and k and n and r. In other words, I think the total kinetic energy in a system of molecules with a number of molecules capital N, but if I re-express that as a number of moles lowercase n, then I think I can just make this substitution. In other words, replace nkt with nRT. And then if I want to know, well, what is the average kinetic energy per mole, I'm just going to set n is equal to 1. And so the answer that gives is k. And maybe, it does say average kinetic energy per mole there, so maybe I'll put a little bar over this, but I think it's kind of optional because, a mole has a lot of molecules, so it's probably going to be approximately correct even without having to state average. But basically, I'm just going to say 3/2 RT with the assumption that if we're talking about per 1 mole, that means n is equal to 1 mole. So let's go ahead and check that answer, and there it is, 3/2 RT. So when you look up results for the kinetic theory of gases, really the 4 expressions I have here, any of those could come up, and they are all connected, but you have to look carefully at the language and how it's described to know which one to use when.